Well, hi guys, thanks for being here. I'm Vishal. I'm the president of the Blockchain Development and Research Society. First, tell you a bit about myself and how I got started with blockchain technology. So I've been following blockchain, the cryptocurrencies for about 5 years. About 2 years ago, I started looking into blockchain theory. And about a year ago, I started working on blockchain development in my spare time. I started going to a few hackathons or competitions with some friends, and first time we created this game, blockchain-based game called Crypto Turtles. It was based on a smart contract on blockchain technology, and it was quite bad, and we were basically ignored by the judges. Then we tried another competition where we basically tried the same thing again, and we failed miserably. But then, as you know, third time's the charm, we created a thing called blockchain-based tenancy agreement system. So this is basically a system whereby you can engage in conflict resolution and also renting property through blockchain smart contract. And it wasn't foolproof. We only had about 24 hours to develop it, but the judges seemed to like it and we came second in this. Some people heard about us, and then we got offered a temporary position where we were offered to go to the largest blockchain competition in the world at the time, called the Blockchain Years Hackathon. The Blockchain Years Hackathon occurred in the Netherlands. There were about 700 people there, including people from Deloitte, Goldman Sachs, Morgan Stanley, you name it. Basically, you're not allowed to just go as a person or as a student group. You have to be a company. So a company that was allowed there hired us me and a friend of mine to go there, some of the blockchain developers. I signed a non-disclosure agreement regarding this, so I can't say much about it. But we came second in one of the tracks, which was global digital identity, using blockchain systems. And I think our solution has actually been displayed to the European Commission recently as well. And the team won, I think, about £15,000 for coming second in that. And there's new competitions going on now where the prizes are even larger, actually. So yeah, that's how I got, and then I came back to York, and I want to share basically my knowledge and hopefully make blockchain here the blockchain community in York a big thing as well. So how many people here know about, let's say, Bitcoin, for starters, cryptocurrency? Okay, how about Ethereum? All right, any other cryptocurrencies you guys know about? Go on. Nice. Anything else? Yeah? Yeah? Which one? Yep. There's actually there's been a lot of controversy around Ripple lately. There's just one company that owns a large amount. So that's quite interesting. Does anybody here own any cryptocurrency? You guys have you guys have a large portfolio, or you guys might have been making some losses over the last few months then? Right? Does anybody here mine cryptocurrency? How many people here actually? Oh, there we go. We have one then maybe. You guys know what mining cryptocurrency actually entails behind the scenes? Right. Well, we'll be covering pretty much all of that here. So let's get started after I have a bit of water. So what is blockchain? It's the revolutionary technology behind cryptocurrencies. It was first made public in 2008. By a alias, a person or persons that use an alias called Satoshi Nakamura, and it was made public in 2008 at the same time as they released Bitcoin. At its very basic, blockchain is simply a database or record of information, a record of transactions. It's not owned or controlled by anything, by any individual or any group. Everyone can view the contents of the blockchain, so it's completely transparent. Anybody who uses it is essentially anonymous. And data, once stored on the blockchain, is completely, cannot be moved, cannot be changed, cannot be edited. So it's what computer scientists would call immutable. And that's a very strong, very important feature of this. So, can blockchain actually be useful outside cryptocurrencies? This is an article that was released by the BBC just a couple of days ago, actually. It was Philip Hammond. He's the Chancellor of the Exchequer, I believe. And he came out saying that they could probably solve the main issues of Brexit, make everything okay between the EU and the UK again, by solving the Irish border problem using blockchain technology. Obviously, this is probably not realistic at the moment with the current state of blockchain technology, but could something like this be actually attempted? You could potentially store information regarding each item passing through the customs border on a blockchain. You could have some smart contracts developed whereby, which is basically just pieces of code on the blockchain that would initiate a process when certain conditions are met. That could basically let you know whether certain items can go through the border, whether some sort of fee needs to be incurred, whether the customs fee needs to be incurred for a certain item, or whether an item has to be rejected, whether a form has not been fully completed. So technically it could be useful in that regard, but we're not currently there yet, at least from what I can tell. Who knows, maybe the UK government has been very innovative and their blockchain technology development has been much greater than we expected. There's also usage of the technology in supply chain systems. So there has been scares throughout the last decade regarding food sources. For example, I like to know where my coffee is coming from. Everybody wants to know, is your food fair trade? Which sources are they coming from? Has there been some sort of epidemic in that area? If, let's say, you have some sort of produce that's growing from lots of different places, and you put them together and sell them, let's say in the UK, and then there's an epidemic that starts at one location, one source, you have to call back all of the produce. If you had a reliable chain where you can verify the source of each batch of the produce, you could call back just that amount, save a lot of money, save a lot of lives, make sure people don't starve, make sure the prices don't rise. I think a few years ago there was a massive scandal in China whereby there was baby formula that came from a bad source, and a lot of infants either died or badly had a bad illness due to it. So everybody wants to know where the food is coming from. And to save the day, here's Walmart. They want to use blockchain technology to do this. So what do they want to do? They basically just want to find out what the source is of each of the items, at what points are the items being, at what points are the produce being tested for potential diseases, and if a diseased produce does get to the end user, they can find out where it came from, and also where a mistake occurred. At what point did a tester see an issue but didn't act on it appropriately, and then they can take action very, very quickly. They've already tested this solution in some areas in South America regarding poultry, and in China using, I believe, vegetables. And now Microsoft and EY and a company called Mars are working on blockchain for marine insurance. So for marine insurance, it's a massive, massive market. We have a large amount of shipping that goes on through, massive amount of, whenever you order something on Amazon, a lot of it comes through shipping. And all of this needs to be insured. So it's a very large market, and there's a lot of risk involved, which needs to be insured to make sure, one, stuff arrives on time, and two, that stuff, if there's a collision between my ship, or if something goes wrong, there is some insurance there. And actually, Microsoft's not the only one doing this. They're competing with another large company, IBM. And we're going to show you a quick video by IBM regarding what exactly they're trying to do here.
Global trade functions much as it has since the introduction of the shipping container in 1956. Manual, paper-based processes are still common, and information about the status of goods is locked away in organizational silos. Today, 90% of goods in global trade are carried by the shipping industry, with the supply chain slowed by the complexity and sheer volume of point-to-point communication across a loosely coupled web of land transportation providers, freight forwarders, customs brokers, governments, ports, and ocean carriers. IBM and Maersk are addressing this problem with a distributed, permission platform accessible by the supply chain ecosystem designed to exchange event data and handle document workflows. Maersk and IBM are employing blockchain technology to create a global, tamper-proof system for digitizing trade workflow and tracking shipments end-to-end, eliminating frictions, including costly point-to-point communications. The collaboration will launch with the potential ability to track millions of container journeys per year and integrate with customs authorities on selected trade lanes. In a recent test by Maersk, shipping a single container of flowers from Kenya to the port of Rotterdam resulted in a stack of nearly 200 communications. Using this example, we will examine how blockchain has been implemented to create trust and security in the digitized document workflow and improve the efficiency of global supply chains. Here we can see each distinct entity involved in the transaction: the growers, export authorities, ports, customs, and importers. Shipping from the port of Mombasa requires signatures from 3 different agencies approving the export and 6 documents that describe the origin, chemical treatment, quality of the produce, and customs duties. Firstly, using a PC or mobile device, the Kenyan farm submits a packing list that becomes visible to all participants. This action initiates a smart contract that enforces an export approval workflow between the 3 agencies. As each agency signs, the status is updated for all to see. Simultaneously, information about the inspection of the flowers, the sealing of the refrigerated container, the pickup by the trucker, and the approval from customs is communicated to the port of Mombasa, allowing them to prepare for the container. All actions relating to the documents and the physical goods are captured and shared: which documents were submitted, when and by whom, where the flowers are and who is in possession of them, and the next steps in their journey. Flowers are perishable, so it's crucial that there are no delays or missteps. Blockchain provides secure data exchange and a tamper-proof repository for these documents and shipping events. This system could significantly reduce delays and fraud, saving billions of dollars annually. And according to the WTO, reducing barriers within the international supply chain could increase worldwide GDP by almost 5% and total trade volume by 15%. For more information on how IBM can help make blockchain right for your business, please visit ibm.com/blockchain.
Sorry about that. So there we can see how IBM was working with Maersk regarding shipping, but recently Maersk has also teamed up with Microsoft. This is basically a blockchain technology war going on there. It's very interesting. Next, let's talk a bit about the history of money. We started off with bartering. Then we had coins. These coins were essentially backed by the government. They would tell you, you can use these coins to exchange money and exchange with other people, and we'll back it with, let's say, salt or rice or whatever, depending on different countries. The same was done with paper money, and we started in China. Later on, we had proper banking, and even now we're using credit cards, and the money we use now is technically backed by government in regards to with gold. And now we're moving on to hopefully or potentially blockchain. But what do all of these have in common? Trust. In the case of bartering, you have the good you're transferring with right in front of you. You're exchanging goods with some other good right in front of you. In the case of coins, you're trusting a third party, which is in that case the government, that they will back the coins. You're trusting that due to this, whoever else you talk to in regards to engaging in a transaction using this money, using these coins, they will trust the coins. The same with paper money and banking. And in the case of banking, you trust the banks. You trust that they will not just steal your money. You trust that they will fairly engage in transactions. If the bank has a problem and they shut down, you don't just lose your money. You don't just lose your accounts. You trust that they will have proper security, so that they can't just easily get hacked. And that is one of the issues that blockchain is trying to solve. In all these cases, whether it's with an insurance system, you trust that they'll pay you back if a problem occurs. Whether it's the bank, you need to trust that they will store your money safely, and that they will pay you back. They won't just use your money to give high-risk loans. With blockchain, you can control what's happening with your money. You have better freedom regarding it, and also withdrawal and so on is much cheaper as well. There's a lot less processing going on. So it's far fewer costs. For example, let's say I want to retrieve $90 million from a bank. On average, this would cost me about $1 million in transaction fees. If, let's say, you used Litecoin, as you mentioned, in regards to withdrawing $90 million worth of Litecoin, you would have a transaction fee of about 4 cents. There's a considerable difference there. And another issue is centralization. Obviously, you don't want to trust just one central authority, and you don't want all of your stuff, all your transactions to go through them. You don't want them to be in control of all of your data, and you don't know what they're doing with it. You don't know what kind of data they have about you. You don't know what they're doing with it. You don't know how much they're selling. Obviously, in Europe, we're better off with GDPR, but in most of the world, they don't have those protections. And there's also a single point of failure there. I mean, if a bank systems go down, you can't withdraw money. There's no, in some cases there is a backup, but there's no proper backup there. If a hacker gets in, they can change everybody's data. And there's no, well, there is some safety mechanisms there, but nothing as powerful as blockchain. So what really is a blockchain? It's basically just a block. It contains a certain number of transactions. Each block is chained, points to each other, and therefore creating a chain of blocks, hence blockchain. Now, in this, you'll see there are certain other things inside a block. There is a thing called a hash, and there's a thing called a nonce. We'll get to nonce in a minute. A hash is basically basically a gibberish number produced from the contents of this one block. This hash will then be transferred to the next block, who will have it within the block. This means that if a hacker decided to, let's say, change the contents of a past transaction and give themselves a somewhat early Christmas bonus, they would change the contents of the transactions in one block, hence changing the hash produced by that block, and therefore will no longer match the hash in the next block. So the system will know that the blockchain has been corrupted, and it will not be utilized. Talking a bit more about hashing, for those that don't know about it. We're going to talk a bit about the SHA-256 hash function. This was developed by the American military in the 1900s. Basically what it provides is you have some plain text. Let's say I'm saying hello. It will get, you throw this into this hash function called SHA-256. It will give you some gibberish. Every single time you put hello into it, it will give you the same gibberish. But it's computationally not possible to go back from that gibberish back to the original hello. So that means, given the hash, nobody can actually know what was in the transactions, and given the same transactions, you will always get the same hash. So that provides a certain level of security here. That's where immutability comes in. You cannot change the contents of a transaction once they've been stored on the blockchain. Moving on, what exactly are nodes in a blockchain? Every single person every single computer or device that is connected to the blockchain network is considered a node. Full node, as we could call it, will contain every single transaction, the entire blockchain, every single transaction that's occurred. So let's say if you own some Bitcoin, you may have a Bitcoin wallet, in which case you will either have a copy of the entire blockchain, the Bitcoin blockchain, every single transaction that's occurred, or some optimized method of this, whereby you have only some of them. Of course, many of you might just have bought some Bitcoin off a website such as Coinbase and kept it on there. That means Coinbase has the wallet. If they go down, you have basically no evidence that you ever owned any Bitcoin, and you probably won't be able to get it back. So how's a new transaction created? First, you have transactions occurred through a wallet. So let's say I let's say I'm doing a transaction with Bitcoin. I first request a transaction. I have public ID, you have public ID. I decide to send you some Bitcoin. It'll make you very happy for that day. This will occur through a wallet, and the transaction will then be broadcasted to every single node in the blockchain network. So every single person that also owns a wallet will find out about this transaction. The transaction will be validated by other nodes before being added to a block. The block will be verified by a process called mining. That's where the mining process comes in. And then once this has been complete, the block will be added to the end of the blockchain. But of course, at this point, I could just come in, create a new block for anybody else, or just grab the newest block that with transactions have been validated, whereby the block has yet to be added to the blockchain, change some transactions, verify myself, and add it to the blockchain. How can this be stopped? That's where there's some really fancy stuff going on with mining, and that's where that comes in. So mining is the process that occurs when verifying a new block, and lets us know that lets us make sure that a new one, a fake one with fake transactions, is not added to the blockchain. So we create hashes within the block. In the case of Bitcoin, here we're basically talking about a consensus algorithm called proof of work. This is what's used for Bitcoin and Ethereum. There's others such as proof of stake, proof of delegated stake. We'll talk about those in a future talk. The block, as we mentioned earlier, has a thing called a nonce. This is just a variable, a random number. We just keep changing it by trial and error until the hash generated by the transactions and everything else inside the block meets certain conditions. In the case of Bitcoin, you want it to have a certain number of zeros at the start of the hash. The more zeros you want at the start of you get at the start of the hash, the more exponentially difficult the computation is. So that means mining is a very computationally expensive task. It takes a long time, and all the miners of a network will be working together on it. This means that they're pooling their computational power to work on finding the right hash. If you want to verify a fake block, that means you need to have more computational power than everybody else combined. So you need to own at least 51% of the computational power of the network. So that's called a 51% attack. If you're using a proof of work consensus algorithm like Ethereum and Bitcoin do, then with 51% of the network under your control, you're able to take over the blockchain and add whatever block you want, really. But in the case of Bitcoin, or basically most cryptocurrencies, this has not occurred because there's so many miners and there's so many people in there. So there's so much computational power going on in there that you're just not able to take over the amount required. There's other implementations, there's other consensus algorithms whereby in some you need 66% of the network to be able to take it over. There's some where you need 75%, there's some where you need 80%. There's some whereby the computational power required is lower, but there's a lot of other fail-safes. So we'll talk about these in future talk. We'll be showing one more application outside of crypto.
How can drug manufacturers securely, transparently, and rapidly track the origin of medicines? Counterfeit drugs are a $200 billion problem. Current issues include information is not shared between systems, companies don't know what happens to their products, recalls are complicated and costly, companies can't follow up with patients. New rules in Europe and the US ramp up in 2018. Pharmaceutical products must be traced across the entire supply chain within a global network of companies. The problem? No data sharing framework. The solution? The blockchain. Imagine the blockchain is a mall. Pharma companies are stores. Stores and customers need a digital key, a digital token, and must follow the rules. Each transaction is recorded by the mall and broadcast to all stores. Everyone has matching records of all transactions ever made. The BlockRx pharma ecosystem brings the blockchain to drug manufacturers. It has three parts: The blockchain securely hosts and shares data. Advanced Digital Ledger Technology, or ADLT, by iSolve integrates legacy systems. The BlockRx token incentivizes blockchain entries and data exchange. Why the BlockRx pharma ecosystem and the blockchain? Trade partners can now share data in a transparent environment. All trade partners validate each transaction. Everyone has a unique identifier and controls who can see their information. Helps offset the financial burdens of regulatory compliance. Lowers the cost of bringing drugs to market. To learn more about how BlockRx will help trace medicines from raw ingredients to patients, visit blockrx.com. Follow us on Twitter and Slack.
Yeah, counterfeit drugs is a major problem around the world, especially in less developed countries. It's a multi-billion-dollar industry, and the impurities in these drugs can cause massive diseases and possibly deaths. And combating it is a very good cause, and it's one thing that blockchain is very, very good at. Just to recap, blockchain is a public ledger of any type of information. It's just a record of this database of data. Cryptocurrencies are all built on blockchain technology. Information on blockchain is stored at a lot of different nodes. The identity of everyone on the blockchain is hidden. Blockchain is kept honest using consensus algorithms, and the information. And yeah, it allows you. It's decentralized and is trustless, meaning that you don't have to trust any third party. As long as you trust the technology, that's all there really is. One interesting thing regarding the mining process, or actually, interesting thing about the blocks themselves. If you guys know, with Bitcoin, it's at the moment very, very expensive to engage in transactions and very slow to engage in transactions. At the start, when the value of Bitcoin was lower, it was much easier. It's not very scalable. The cause of this is the size of the block. Because it's not owned by, the blockchain is not owned by anyone, it cannot just be edited by anyone, nobody can change the system. You cannot change the size of the block. So the way it's developed is that you can, a new block is created every 10 minutes. Each block can contain about 2,000 transactions. That means about 3.5 transactions a second. You cannot have more transactions than that unless you change the implementation. That's why you can't really make it go faster unless you have some really smart update, or you change the implementation itself. Somebody takes over and changes the implementation. That's why there was a fork not too long ago called Bitcoin Cash. Anybody's heard of that? It's another cryptocurrency. That's when some people from Bitcoin decided, hey, this is not working out, it's not very scalable, so they create a fork. So anybody that owns any Bitcoin would have some Bitcoin Cash as well. So literally just copy the entire ledger, including every single transaction, make a complete copy of it, decide to go from there when they made some changes. So they made changes in regards to increase the size of the block itself, so to store more transactions, and therefore one of the scalability problems was temporarily solved. Right, hope you guys enjoyed that, and I explained things all right to some degree. We have guest speakers secured from 2 fintech companies, one guest speaker from the airline industry, one cryptocurrency, and our next talk will be on consensus algorithms on Friday 19th. You can contact us with ideally feedback, and if you want to join the mailing list on blockchain@user.org, yourblocking.co.uk, and we have a Facebook group where we're always adding more news stories, and we're commenting on them, writing opinion pieces, and so on. Yeah. Any questions so far? Yep.
So with the idea of proof of work,
yep.
Relying on, so you take a block, and also which is transaction through
yep.
hash, you run anything else, then you run it through SHA-256, and
yep.
hope you get, hope the hash matches the conditions.
Yeah.
So the idea is that there's an average amount of time you have to regenerate the nonce and rehash it before you'll get 2 for 1. What if an attacker just happened to generate the right hash the first time, or anyone else?
That is one very, very unlikely, but if that were to happen, then they would, I believe, be able to take over that one block. But since they don't have sufficient computational power to take over the blockchain, it would just be that one block. There are fail-safes in most implementations around against that, but in general, I think that is what would happen in Bitcoin. Any other questions?
So which background are you using?
Computer science. Computer science.
No,
Oh, right.
because you did a placement, right?
Yes, so I did a placement in London at a company called Amadeus.
Ah.
So it was basically mostly seat allocation in airlines. So that was just mostly C++ development. But on the side, I went to a lot of meetups and did a lot of hackathons and competitions, which were mostly blockchain competitions. And that's where I went to basically a monthly meetup on blockchain technology. So contacts there, I learned a lot, and we developed a lot of blockchain-based projects. Any other questions? Yep.
I'm more just wanting to play devil's advocate.
Yeah.
You're talking about blockchain being for suppose you built a system like that, but it didn't use blockchain, and you had to trust everyone involved.
Yeah.
First of all, would that be computationally less expensive for everyone involved?
It depends on the implementation. One thing we do know is if you're relying on, let's say, just one database to store the data, if that database goes down, you lose all the transactions. Here it's all nodes, there's countless backups. In that situation as well, if, let's say, it's going through a supply chain and some testing's been done and somebody screwed up at one point, and if they have the rights, they could always go back and change some records. It's always the case as well that you can store. The issue here is that there's a lot of different implementations. We've just shown the implementation for Bitcoin. So this is a very so what each of these companies is doing, they've got there's a lot of other stuff being done, and there's a lot of other implementations. Well, yeah, they're also using smart contracts in there regarding to this processing of data. So depending on how you do it, it's most likely computationally faster and more secure. But obviously, if you screw up, yeah.
So if you did trust everyone involved, and you probably do anyway because you're buying the lettuces from them, then I suppose you can make the whole system fairly reliable and take not all of them all places distributed, then you still have probably the same level of reliability, maybe. What's to stop someone just taking a container full of lettuces and placing it in different ones?
Well, the idea there is it would be checked at every single point, and an update would be added to the blockchain. But aside from that as well, let's say in the case of Walmart, they don't deal with every single farmer individually. They deal with some sort of distributor, which deals with each farmer, or deals with another distributor, which deals with the farmers directly. So you want to figure out what's going on from the first point. And also, even if you trust everyone, whatever system you create, it still isn't immutable. There's still no fail-safe. If a hacker gets in, they can still just steal a lot of confidential data. They can still make changes. They could still, if they just corrupted the entire database, it could throw the entire system into chaos.
Sure. I think my point was more that it doesn't matter. Okay, suppose you use blockchain that's super secure.
Yeah.
And it doesn't matter that you don't trust anyone because it's blockchain.
Yeah.
You still need to trust the person that is handling your
Definitely, yeah.
medicine, right? Because they could just replace that with one that looks exactly the same. It's the same label on it, and it doesn't matter the whole thing's tracked with blockchain. That it doesn't actually make the delivery of medicines, for example, safe.
Yeah,
It just makes it, just means you can track it.
So that's a very good point there, actually. So in this specific case, what blockchain is doing is hopefully making it more secure, and it's hopefully adding fewer points of failure. And as you said, if you trust everyone on the chain, on the system, you could probably, in most of these cases, implement the same thing without a blockchain-based system. But the sad reality is, in most of these cases, you can't trust every single person involved. So,
I suppose if I'm someone who's practicing, if you put up the middle, then you have a middle. That's the different connection, and you can hash this generator. And that's probably what's the problem in the chain, I suppose.
yeah.
So if you see those middles,
But I can use the same label, but different medicine as well. You should just not have any questions. Take the medicine. Right? It doesn't make the medicine more secure, it just makes the tracking of that label secure.
more obstruction with knowledge, some medicine block that you put on some chain.
Sure.
Same can be said.
Yeah. People do make it sound like it's revolutionary in the ways that it will solve every single problem. That isn't actually the case. We're not saying that's the case, at least not here. But the idea is that, as you mentioned, it will hopefully solve some problems and will make the systems more secure. Yeah.
So if someone designs a blockchain system and then 2 months later decides, oh, I want to add something new, would they need to remove the whole old one and start from scratch? They want to add a feature or realize there's a better way of doing something.
I mean, depending on how you implement it, you can always make it so that changes can be added, but that's more difficult to do. If the traditional implementation suggests with Bitcoin, yeah, no, you can't make changes. Once you've designed it, it's done.
If you allow for changes, would that make it less secure as well?
Yeah. That gets rid of the decentralization. So the point is nobody owns it, nobody controls it, nobody can make changes. You can trust it because you can trust the system because nobody can alter it.
There's no updates, basically. You get it right first time.
Sure, yeah. Although with Ethereum smart contracts, you can always upload a new version of the smart contract, which is interesting.
Well, I understand. The essence is to hold information, right?
Yep.
And so if you want to make changes, you don't want to change something on the machinery hard. So if you make changes on the system, it's rectified at the end of the block. So you don't need to change anything on the other block. So whatever changes are starting at the end of the block, that's
That's accurate. It also provides the opportunity to engage in processing of this information through the implementation of smart contracts, as we did with Ethereum, and now some other projects are doing it as well, such as ARC and Lisp. So there's a lot of back-end stuff going on. Still, keep in mind this technology is really in its infancy. Everybody is telling you that's going to revolutionize the world now. It's the same people that said that self-driving cars were going to be on the road 15 years ago. The technology exists, it's always going to go through road bumps, and it's a slow but painful path towards adoption. Yep.
Do you not think things like mining network and stuff are appropriate scaling solutions?
They are, they've been worked on for a while. and they could provide appropriate scale solutions. We just need to see them. We've been hearing about the Lightning Network for a while now, and we haven't yet seen any considerable. Well, we haven't yet seen it in production, and we haven't yet seen it. Is it? I haven't been keeping track on Bitcoin since like 3 months. Okay, fair enough. I'll have to check how that's affected the scaling problem. So I haven't even pardon? Yeah? All right. Okay. I should know that. Yeah.
I guess that's 51% of the network decides there shall be a fork.
Not necessarily. In this specific case, a smaller group decided we want to create a fork, so they just copied the entire network and just made a new thing. And initially, it had far fewer nodes and far fewer users. Most people stayed with the original. But most people didn't really know how things work, so they didn't know how to change to the new to Bitcoin patching if they wanted to. But
that brings me to my main question: is how typically is a fork like that coordinated? How do all of the nodes come to an agreement that there will be a fork? It's going to be at this point in the game.
oh, that's pretty hard to do. Yeah, no, but if you have a large enough network, which is in the Bitcoin community is quite large, and there's a lot of really tech-savvy people. There was actually a very long and very complicated debate on whether any changes should be done, and if a change is done, then what change should be. Should it just be increasing the size of the block and so on, or should it be something more in depth? And always the argument was, would this not be affecting the decentralization of Bitcoin if you just change, if you take over and change how things are? That's why the community, the group that actually created the fork was actually quite small to start with. But people started going to it, mostly just to make money. But.
So theoretically, there's nothing stopping you from creating a blockchain that has its own logic written in the blockchain itself. So you could like blockchain, right?
What exactly mean by logic? So are we talking about smart contracts or?
No, something that you don't have to call every time you want to update.
I suppose, but then who would be doing the updates? Who would have the power to do the updates? That means you're giving somebody control over it. And that makes, at that point you make it centralized. Obviously, yeah, if you're a company that wants to create a private blockchain network within your own company, but you want to make it so that your employees aren't allowed to change the data on there, then yeah, you could do that.
You can do like security costs, right? If you want to
Suppose.
you can do like soft calls for the nodes.
Yeah, that's a great show.
Yeah.
Yeah.
Does the fact that all the nodes need to communicate make blockchain slower than a centralized system?
Not necessarily. So whenever a transaction is done, there's a broadcast done, but there's no necessity to wait until everybody receives it. So there's timestamps, so everybody will just coordinate itself.
So if I want to say, if you want to get a digital set, so should that be authenticating ledger as well?
If you had, not really. You could, if you changed, in the case of Bitcoin, if you changed a previous one, it would still mean that it would be changing the hash generated by that block, from that block. And that would mean that the next block would no longer match, the previous hash stored in the next block would no longer match the previous one. So there would be a, depending on obviously which implementation, there might be a way around that. There's a lot of potential attacks that could be attempted. So there's actually, we want to have an entire talk on potential attacks on cryptocurrency networks that are potentially possible. Yeah.
Do you think the best use of blockchain is in stuff like insurance traveling? Do you think it's currency, or how do you think that's when the
potential as a currency in regard if you don't trust banks, or if you want to buy something off the dark web. No, it definitely has potential as a currency. I mean, Bitcoin, the way Bitcoin went is more turning into a store of wealth rather than an actual currency. But there's a lot of them, especially if they have just Ethereum where they have these smart contracts. That's really interesting. And it could very well be used as a cryptocurrency. It really just depends on adoption. If people want to use it as a cryptocurrency, it will succeed. If they don't, it won't. With most implementations, transaction fees are very low. There is proper trustlessness, so you don't have to trust a third party, and they're very secure, so there's no reason not to really use them if you actually understand what's going on there. But I think that the technology can be utilized in basically unlimited number of industries. A lot of ideas that companies have of how it could be used come from them not properly understanding technology, so they come up with ideas that aren't really viable. So there's a lot of use cases. Most of them are generally not going to work out, but there's a few that we'll see 5-6 years from now that generally work out and do revolutionize the industry. That's my point of view. So of the ones we saw today, possibly maybe one of them ends up working out. Well, I do think some will. All right, apparently we're out of time, according to Peter. All right, yeah, if you guys want to network or talk to each other a bit, you can come down and do that, or well, the talk itself is over. From what I can tell, the people here are the biggest blockchain enthusiasts at York at the moment. So if anybody here wants to do a blockchain-based venture, get to know each other. And come to our next talk on the 19th of October regarding consensus algorithm deep dives. We talk more about proof of work, more about proof of stake, delegated stake, proof of yeah.
Well,
Yeah, that's all.
Woo! Just about.